Not quite sure how I feel about the beanbag thing, but it's okay. Cool. Well, thank you very much. Welcome to Brighton Kotlin. It's great to see some new faces, some people from Brighton Jug as well. Yes, let's kick off. So today we are going to have a few introductions. If you've been here before, you'll know that Silicon Brighton are a big part of what we do on the tech scene down here. They support these meetups as well as a gazillion other meetups down on the South Coast. So for those who haven't heard from Silicon Brighton before, we'll get Grace to come and do a bit of an intro, just to give you an idea what they do and how they support us. And then we've got a talk from Marty about using Kotlin type aliases to automate microservice integration. I have to admit, I'm not quite sure what that's about, so I'm intrigued to see with this one. Marty is founder and CTO at Orbital. I'm sure there'll be links where they can find you online and during the talk and things like that. So all good. Grace, do you want to do your Silicon Brighton bit?
Thank you. Yes. Hi. Yeah, thank you. Apologies for anyone who, well, the regular faces who know what we do, but really nice to see new people as well. It's great that the word is spreading, and also just to see crossover with our other meetups as well. So for those of you who don't know me, I'm Grace and I run Silicon Brighton. We are a not-for-profit and we're all about supporting the local tech ecosystem here in the Southeast. So this isn't the only tech meetup in Brighton. There's about 20 altogether that we support across different skill sets, coding, programming, languages, UX, you name it. There's probably a social for it, again, with talks like this one. So really it's just a shout out to get involved. Have a look at the different meetups that we run, and if there's any others, not necessarily in a space that you work, but maybe want to find out a little bit more about, or just generally upskill and meet some similar people who can tell you a bit more, then check us out online, siliconbrighton.com. Look me up, Grace Pryor on LinkedIn. And yeah, similarly, if you've got ideas for other meetups or ideas for talks, or would like to get involved in helping us to promote what we do, spread the really good word that all these are free for the community, or sort of help to organise, then again, get in touch. We'd love to hear from you, because we are run for the community and by the community. And that is a massive thank you to our members. So everything that we do, including the AV and of course the very important beer and pizza, is all funded by our members now. And that's all the businesses supporting us and what we do to continue to make it free and therefore accessible, inclusive to everyone. And that is it. I'll hand back over to Lee.
Awesome, thank you. So a couple of announcements. If you've not been here before, toilets are over there. If there's any fires, we go that way. We also have thanks to Devox UK, we have a ticket to Devox to give away tonight. So we'll make the draw after tonight. We'll gather all the names of people who are in person and people who are online, and we'll draw a name out of the hat. We'll contact you if you're the winner to see if you can make the Devox dates and have the time off work, I assume. If not, then we'll move to the next in the list. So without further ado, over to you, Marty.
Thanks. Thank you. Ready, ho. Okay, hey, I'm Marty. Welcome to this talk on automated integration using Kotlin type aliases. And really, this is kind of a proxy to semantic contracts. So we're using Kotlin type aliases inside of Kotlin. A bit of the talk's going to be around kind of semantic contracts and what they are and how we can make our lives better. That's me. So I'm a developer, have been my whole life. I wrote a thing called Swagger Spring originally that was then Spring Fox, which is kind of the Swagger tooling for the Spring ecosystem. These days I work on a language called Taxi, which is a open source language for defining semantic contracts and embedding them in our API specs. And I work in a company called Orbital, which I'm going to show you throughout this demo, but is a way of taking those semantic contracts and integrating stuff, removing glue code, basically. So we're on a mission to save developers from glue code, basically. Right, let's get into it. So the problem that we are out to solve is that there are microservices everywhere. Okay, this is fundamentally a good thing. Like, we've worked really hard to get to the place where it's easy for us to build and ship and create microservices. And by microservices, I kind of mean lots of different things, right? I don't just mean a Spring Boot app. I mean things that we interact with through some kind of API. So it's like a REST API, or maybe a database for an application, our serverless functions that we call, or message queues like Kafka or Rabbit. Basically, the different things that we use in an enterprise to build stuff. So there's lots of these everywhere. And that's great. But it means that we're doing lots of plumbing, right? We're writing lots of kind of code to connect this stuff together. And it's boring to build, right? It's not particularly fun work to be stitching together Swagger specs or connecting a protobuf spec to a Swagger API to the 3 other Swagger APIs I need to get done. And they're also really boring to maintain. And they tend to be brittle, right? This code that lives on the edge of our boundaries, or on the boundary of our systems, it's where stuff breaks. And it breaks because people that aren't us ship changes. Like, we're fine. Our stuff's fine. It's other people who break our stuff, right? And this is kind of a proxy way of saying, look, this is really expensive stuff to do. It costs a lot of money. It costs a lot of time. And it's not time that's spent shipping features. It's just time that's spent gluing stuff together. And so the solution is quite obviously automated integration using Kotlin type aliases, which is a proxy to semantic contracts. Okay, so let's dive into that part and kind of explore what I mean by that. API contracts are kind of well understood. I suspect everyone in this room has had some interaction with OpenAPI or Swagger at some point, I presume, yeah? Probably some protobuf floating around the room, definitely some databases, yeah? Even if you're not doing any of that stuff, right? Even if you're not shipping some kind of formalized API spec, you've probably got a data class or a controller or something in your code that specifies the data that my service is going to take and the data it's going to give back, right? So even if you haven't kind of published a spec, the reality is there is always a contract, right? Even if you haven't written it down, your code has a contract that is expected. Most of this stuff focuses on how. So it talks about, how do I call your service? Like, what's the address where it is? How do I serialize or deserialize stuff when I'm talking to you? What's the byte array offset? What are the keys that are in the map, right? Is it a get or a post? Like, how do I talk to you? And it tends to be formal. So it tends to be well documented. It tends to be a thing that we publish. And if we change it, we kind of expect stuff's going to break, right? It's a formal contract that exists between 2 parties. It's very how focused. The other side is the what. And this tends to be a lot less well documented, right? This is the, once I've deserialized a thing, once I've read the keys that are in that map or moved to that like byte array offset, what am I going to find there? Like, is it a first name? Is it a last name? Is it an email address? What's the data that's actually sitting inside of that? And this tends to be like, we kind of capture this in a wiki page, or like some Confluence thing where it kind of goes to die. We've got maybe some docs. A lot of the time when we're doing integration, it falls down to consumer trial and error, right? So chances are, if you are integrating someone else's API, you probably open up Postman or something like that. You have a bit of a sniff around, you invoke some stuff. You kind of look at it and you go, okay, well, there's the thing that I want, right? It's called email, right? That's the thing that I want, and I'll go off and I'll start doing it. Consumers end up doing that work, right? So where producers are responsible for kind of defining the structural contract, because we don't have a formal way of sharing the semantic contract, it kind of falls to the consumers to work it out. And again, I'm pretty sure that everyone in this room has fired up Postman and looked at a JSON payload to try and work out which field they're going to use. The other way that we tend to do it is with Brian, right? Brian always knows. We go and have a chat to Brian. Brian tells me what the answer is, and I've got to sit through like 30 minutes of stories about his kids before he'll tell me that ifname 23 is the field that I was really looking for. It used to be first name, but in 2023, we changed it to ifname 23 because first name was inconsistent. So we shouldn't use first name. We should use ifname 23 unless ifname 24 comes along. This couldn't be clearer. So this is kind of how we structure it, right? The point of this talk is how can we move kind of this informal side to being something that's more formal? How can we document this and do this in a way that has the same kind of first-class support as the stuff on the right? And the answer is through types, through lovely types, specifically scalar types, right? So they can't have attributes. As soon as they get structure, they become a structural contract. So we're really talking about how do we break our world down into really, really small, tiny, bite-sized semantic things that we can share. The smallest atom of an API contract is the field. So not the collection of fields, just a single field. And how can we define contracts around what that is? The point is here that this isn't a one or the other thing. Both of these contracts exist. They exist today, they exist in your organization. If you are doing any kind of integration, you already have both kind of contracts. It's just we formally define one of them and Brian tells us about the other, right? It's informal on the left-hand side. So just kind of break that down a little bit more and look at kind of structural versus semantic. Structural being about how, semantic being about what, right? How do I talk to you versus when I'm having a conversation, what am I going to find there? So field names, structural or semantic, bit of audience interaction. What are we going to do? Structural, semantic. Someone give me a go. Anyone? There's like 100 people in the room. There we go. Semantic. Field names are semantic. Yeah. I don't think so. I think field names are structural. So here's an example of a contract on the left and some data on the right. Yeah. So these field names in my structure, really all they do is they tell me, they give me a hint as a human what I can find there, right? But they don't really tell the software anything. The computer doesn't really know anything about this. Fundamentally, all these field names it's a hint to the software to work out how to read a value from a map. The value is the thing that we care about, not the field name, right? The field name is just a how do I get there? The what is the thing. So we can look at this and we can go, okay, cool. I get that it's Jimmy. I get that this is a customer. His name's Jimmy. His email address is j@foo.com. I can kind of look at this and understand what this means. And I can prove that field names are not semantic because I can do this, right? I can skip through some slides and I can change the name, this field name from name to given name, right? And I can do that. And in fact, two different systems might describe this information in exactly the same way. And that doesn't change Jimmy's name. Renaming a field hasn't changed the meaning of the value. Jimmy is still Jimmy. Jimmy's email address is still j@foo.com, right? But my structural contract has changed. Software, if I made this change, would break. Likewise, I can go for a kind of more dramatic change and I can embed Jimmy's email under a contacts blob. We can still kind of look at this in Postman and go, yeah, I get what this is, right? I get where the email address is. I get how to work it out. So now I need to go to the contacts blob and read the email field. So all the fields are doing is telling me how to navigate a map. They're not really telling me what the stuff is. The flip side is also true, right? If I change the semantic contract and drop in a postcode where the email address is, stuff's going to break, but in a much less formal way, right? Unless you've written a bunch of validation code to sit around this, which isn't really what we do with our classes. Like, this is going to break, right? All of a sudden, we're expected to receive an email address. Now there's a postcode that's floating around my system. So semantically, I get that even though the structure hasn't changed, I've broken a contract somewhere. So field names are a bad proxy for semantics. I feel like I tricked you guys with that one. That was not the intent. Here's another example, right? If we look at that same kind of idea across 3 different systems, 3 different like platforms with 3 different JSON payloads that are floating around. And if we kind of squint, we can see that there's a relationship between some of these things, right? A customer ID appears in two of these different places, the number 1, 2, 3. One field calls it an ID, another field calls it customer number, right? An abbreviated version of customer number. The customer's ID is still 1, 2, 3. The field name doesn't matter. And in actual fact, like if this was 3 different teams, those teams should be free to pick names that make sense to them. 3 different teams, 3 different domains, 3 different autonomous software groups, right? That are building and shipping software. We can't be expecting everyone to align around field names. Like we've gone down that path with enterprise domain models. Spoiler alert, it just doesn't work, right? So field names don't really tell us much. There's another one here, right? Card number and account ID, really different names, still the same bit of semantic information. So where we kind of end up is actually the values that we're passing around, they have field names, but the content of it has a semantic contract. And if I can label it, I can start doing cool stuff. So if I can say that the ID that's passed in here, the field name is ID, but the value, the semantic contract is a customer ID. Likewise, between my cards and my balance models, they're called different things, but the semantics of it are you're going to find a card number in that field. We can take those semantic concepts and we can embed them in our API spec. So maybe I've got maybe I've got an open API spec. We can embed it kind of directly in there with some metadata. If I've got a protobuf spec because I'm doing gRPC or I'm doing kind of protobuf on the wire, I can embed it in my protobuf spec. Or if I'm doing good old-fashioned Kotlin, I can add a data type annotation. So I've got a type alias and then a kind of little annotation that lets me start adding metadata to that type alias. Regardless, 3 different systems, 3 different ways that are kind of native to those systems that I can embed this metadata and start sharing these semantic contracts to say, no matter what I call it, here's a place where you'll find customer number and here's a place where you'll find card number. So that kind of leads us into semantic contracts. What are they? Well, so they're a collection of terms. There's small scalar terms with a real kind of clear, explicit definition. We've defined them with the same level of rigor as we define our classes. And they're shared between systems. They're designed to be shared, right? So if we look at that, here's a collection of terms from my last slide: customer ID, card number, account balance, and we can strongly type them. So we can chuck a type alias around them and they become strongly typed in Kotlin. Or we can use value classes for them as well, right? Like two sides of the same coin, matter of taste, whether you prefer one or the other. Regardless, they become strongly typed kind of terms that are designed for sharing. They're scalar data elements that have the same semantic meaning. Scalar because they have no structure. As soon as they have structure, they become structural contracts, and we're trying to keep those 2 things very separate. So here we go. We've got these, here they are again, embedded in our contracts. We've got ID, customer ID, shared between 2 different systems. Field names don't matter, but I can look at it and I can go, if I want to read the customer ID from this thing, what's the field name? So we can start doing some inverse around it. We can say, actually, I care about the data. I don't care so much around the contract, the structural contract. The structural contract is really important for software to understand how to talk to different systems. But for consumers, if all I want is the customer ID or the card number, then I don't really need to care about the field name that it comes from. Structural contracts must be semantically the same for them to work, right? So here's 2 different film review systems. One is from IMDb, one is from Rotten Tomatoes. They've both got a field on them called film ID, and the semantic type has been defined as film ID, right? When we look at the data, we can see that they're not the same bits of information, right? They define data in different domains. One's in the domain of IMDb, the other one's in the domain of Rotten Tomatoes. So they're semantically different. So we can't do this because this violates a semantic contract. The semantic contract in this space is saying, I will tell you the ID of a film within the IMDb world. That's its semantic contract. However, because they're types, we can do all the same kind of things that we do with types anyway. We can namespace them, right? We can put them in packages. We can even use inheritance to say, actually, IMDb and Rotten Tomatoes, their film IDs, they're both specializations of the idea of a film ID. So it means that we can do things like say, show me all of the film IDs, or just select things that have a Rotten Tomatoes film ID, or just select things that have an IMDb film ID. Because it's a type system, all those tricks that we know and love from our years of type systems apply. And they're designed to be shared across systems. So if we look at kind of the different types of contracts, structural versus semantic, structural contracts change all the time. And we know that this is true because we've all worked really hard to make it possible, right? I can build a microservice and I can ship it in a couple of days, and then I can ship the next version and the next version. We've made it really, really easy to replace a database with an API, or an API with a database. We've made it really possible to ditch JSON and put protobuf in place, or to ditch protobuf and stick Avro in place, right? We've made it really possible to change the structure of how we talk to things, to swap my verbs, to refactor my domain models. We do that all the time. But the semantic contracts don't actually change that much. Once we find a way to agree what a film ID is, that's true. That doesn't actually change very much in our business. Structure changes all the time. Structure is a function of systems. Semantics are a function of our business. And those semantics don't actually change that much. Structural contracts are really hard to agree, right? If you get two people from two different teams to sit down and try and design the customer domain model, they will not agree. They won't agree on what fields should be mandatory, what fields should be optional. They won't agree on what things should be called. They won't agree on naming schemes. They won't agree on how to encode things. And they shouldn't have to. That's why they're in different teams building for different things. Semantics are really easy to agree. Right? It's really easy if we take away the how and we just focus on the what to label things. And I know that because we all do it every time that we open up Postman and we look at a blob and we go, that's the thing that I want. So we do it every single time we build an integration. We just don't have a great way of capturing it or writing it down. Structural contracts result in tight coupling. If I publish an API spec, and you grab that open API spec and you generate a client from it, whenever I change my open API spec, you have to change as well. Otherwise, or we have to get into a very long internet flame war about what the right way is to do API versioning in the REST world, right? So structural contracts result in tight coupling. I know a lot about your system as soon as I build off of your API spec or your protobuf spec or your database schema. I know a lot about you. Semantic contracts, I actually don't know very much about you at all. All I know is that I want a piece of information called customer ID or card number, and I don't know how that's served to me. I don't need to. Structural contracts are absolutely required for producers. If you are building an API, you have a contract, you should write it down, you should publish it, you should be very meticulous about what your structural contract is. The more effort that you put into this, the better. But consumers, consuming a structural contract leads to tight coupling. Consumers, ideally, all they really want is semantics. Consumers don't care if this data was served to me over REST or protobuf or from a database. All they care about is what's the account balance. All of the other stuff, all of the API specs that we build, all of the integration that we build, it's just glue work that we build in order to get to the thing that I really want. So to summarize, semantic contracts are a collection of terms with an explicit definition, and they're designed to be shared between systems. They are an atomic unit of thing that lives on the edge of our systems. They're designed for sharing. Once we do that, we can start doing some really cool stuff. We can start automating integration. But we have a pretty specific definition of what we mean by automated, right? Lots of people talk about automated integration. There's lots of middleware platforms out there. We're on this mission to eliminate glue code, and we have a relatively specific definitional kind of litmus test of what automation means. So for us, it means, can it connect on demand? Can it build something on its own? So if a developer gets a requirement like given this customer's email address, what's their account balance, and they have to stitch together a bunch of systems, if they have to go off and write some integration code, or if they have to go off and design some integration in like a drag and drop designer, or if they have to go off and write a GraphQL resolver, right? That's not automated. All that's happened is we've moved the work from one place in our stack to a different place in our stack. They still have to do the work. And the second test is, can it adapt? So when I replace my API with a database, when I replace my database with an API, and when I move from JSON to protobuf, when I refactor my APIs, if I have to go and fix something somewhere, it wasn't automated, right? I just moved the work somewhere else. So if we look at kind of how we can start using semantic contracts to drive automated integration. If we imagine we've got 3 different systems, right? We've got a customer system, which has a REST API. We've got a cards SQL database sitting over there. And then on the far right side, we've got a legacy SOAP transactional system. It's a bit hard to read those labels, sorry. And sitting inside here, we start embedding semantic contracts. So we can say, this field called email, it's not just any old string, it's an email address. Here is its semantic contract. These 2 fields, even though they live in different systems, they're encoded in different ways, you talk to them in different ways, they're not just any old strings, both of them are customer IDs. And so on and so forth. We can add these semantic tags across embedded in our schemas. We can take those schemas and we can publish them somewhere. And when we do that, we can build this big old graph where we can understand how all of our different systems relate and how the data between them can be shared. Which means when we do this and we get this requirement of, given this email address, what's the account balance? Without us having to have previously seen this requirement or previously built any integration, we can work out that in order to do it, we take the email address and we first do a REST API call, then we take the results of that and feed it into a database query, and then we take the results of that and we generate a SOAP payload to give me the balance. Now, in order to do this, we need both a semantic contract that tells me what the data is, and I need a structural contract to tell me how do I talk to these systems? How do I generate this REST request? What is it? Is it a GET or is it a POST? What does it need in its payload? How do I talk to the database? What driver is it? Where does it live? What kind of query do I need to build? How do I talk to, I mean, no one knows how to talk to SOAP, but like, how do I generate a SOAP? Yeah, I don't know. But we need to understand structurally, or we need to understand the structural contract, and then we need to understand what's the semantics of how do I read the responses and how do I generate them. So we need both of these contracts. Without both, we can't do this automation. Once we've done that, so then we can start doing cool stuff like consuming data using these semantic contracts. So here's our collection of terms, our strongly typed collection of terms. If we're building in Kotlin, these are type aliases, right? If we're building in C#, I think they're called type aliases there. If we're building in TypeScript, they're called type aliases. But we have this kind of collection of terms that are shareable between systems, right? So we can start using them to write queries, to ask for data. We can say, given this thing that I know, like a customer a customer ID of 123, find me the account balance. And I don't need to talk about where the system is or how to do this because we have this graph that will work it out. Or maybe I can go a bit richer and I can say, right, given a customer ID of 123, here's the data that I want. I want to know the customer's name and I want to know their account balance. And there's a couple of things to note about what's going on here. As the data consumer, I'm defining the contract. So I'm defining the names of the fields that make sense to me, right? I'm decoupled from the producers. So if we have a field, if Brian's named as field if name 23, right? I'm decoupled from that. Or I'm saying the data that I want is the customer name. The data I want is the account balance. Also, because I've defined the data contract that I want, specifying the data that I want, when my ecosystem changes, my data contract doesn't, because I'm not coupled to field names, I'm coupled to semantic contracts. This is the data that I want. It's up to software to work it out. So this query that we're showing here is an example of Taxi, which is our open source language for doing this kind of stuff. Equally, I could do it in Kotlin. So I could take a type alias of a film ID, which is a kind of integer, right? And I could chuck a data type on it, annotation, because that's how our framework works. We need a little annotation there to say this is a thing I care about. And then I can build a data class that describes the data that I want, right? The film ID and the title. Again, field names are up to me to define. And then I can write a query that says, find me a list of films and give it back to me as the data that I want. So find me some information and format it in the way that I want it. And if that query takes 19 different hops and 19 different orchestrations between different places in my service, or if it only takes one, I don't know. Like, I'm not involved in that. I'm a consumer of data. I'm saying the data that I want. So putting it all together, we end up with taxi on the left-hand side, which is a semantic metadata and query language. Right? It's a way of defining these semantic contracts, and it has bindings in a bunch of different languages. We've got Kotlin and TypeScript and tooling for OpenAPI and for JSON schema and for protobuf and for Java, and we've got a bunch of other stuff that we're working on. So this is a way for me to define my semantic contracts and then embed those contracts within my existing API specs. And then on the right-hand side, we've got Orbital, which is the thing that we build, which is basically an automated data mesh. How do I take all that stuff and build the integration on the fly? Whew. No more slides. Time for a live demo. This is always going to be fun. I lied, one more slide actually. So our demo takes place in the exciting world of films. So we have down the bottom, we've got a bunch of different data services. We've got a database that has a bunch of films that my fake film producer company creates. We've got a REST API that tells me where can I watch this? Like which streaming services is this available? Is it on Netflix or Hulu or HBO? We've got another one that tells me what are the film reviews? What are people saying about it? And finally, we've got this Kafka topic where every time Netflix reboots a 1980s sitcom, a message gets dropped, a protobuf message gets dropped on a Kafka topic. And so we've taken these schemas, we've published them up to Orbital, and we're going to play around as a data consumer, and we'll kind of dig under the covers and look at how it works and what's going on. Is there anyone watching online? Yeah, there's about 10 people. Oh, okay. I don't know how I'm going to do this single-handedly, but this should be fun. Right. Okay. So. Okay, so I have a bunch of microservices that I kind of touched on. So the first one that I'm going to look at is how do we kind of publish our contracts. So here's one of my microservices. It's a really kind of normal vanilla Spring Boot microservice. There's nothing much going on here. It's got a class. I've turned on Swagger just for fun. Down the bottom, this is our kind of unique stuff. So I'll just talk through this super quickly. Basically, we're just saying I want to publish my schema, my API contract, and what do we got? I want to generate it from, I'm just going to give it a package ID, which is Petflix demos. My microservice is available at localhost.serverport. And just generate everything that's sitting under the package of my application class. So just kind of general purpose Spring Boot application class, go off and build me a contract from that. And so you could be doing this with your OpenAPI specs, but I've chosen to do it in Kotlin because I'm at a Kotlin meetup, right? So at the OpenAPI spec meetup, we'll talk about how to do it with OpenAPI specs. Here we're just kind of saying, right, generate me the Kotlin classes. Generate me the Kotlin contracts. And that's going to generate both a structural contract and a semantic contract. So it's going to take that and it's going to kind of publish that up. So if we jump into Orbital, and we take a look at our catalog, we can see, there's no way you can see that. So here's kind of my ecosystem of services. Hang on. And we can see that we're using these semantic types to describe things. So like my streaming movies provider that tells me where I can watch things, its input is not just an integer, it's a film ID, right? And what it's giving me is a collection of data called a streaming provider. And so if we kind of start to click around, we can see how everything, oops, we can see how everything kind of relates, right? So the thing that's coming, our data that's coming out of our database has the schema. It has semantic contracts associated with it. So its film ID is a type of film ID, and we could take that and we could feed it into our streaming movies provider to work out or look up where can I view this movie. So these atomic semantic contracts become shareable across the system. Okay, so then we can use that to start doing queries. And so I'll jump back into the IDE and I will do that inside Kotlin code. So here's my here's kind of my interaction with me talking to Orbital and asking for data, right? So basically I'm saying, find me a list of films and stream it to me as this my film data object, which is up here. We've just got two fields on it, a film ID and a title. Before we go too further, let's kind of dig into these semantic contracts and see what's going on under the hood. It's not a huge amount of magic here. These are just type aliases, right? The type aliases with a value of a name, film ID. I've defined that in a static const just to keep things nice and tidy, but it's just a string, right? It's a namespaced name for this type. So I'm just saying, find me some films and stream it to me as this. So I can run this query. It doesn't talk about where to get this information. It's not really my job. Producers have embedded these semantic contracts in their APIs. In fact, sorry, I skipped over that. Let's take a look at that. Let's take a look at a streaming provider. So here's my REST service, right? And it has a kind of normal Spring Boot get method on the top, but the ID that it takes in isn't just any old integer, it's a film ID. So the semantic contract that we're saying here is, if you give me a film ID, I will give you back its streaming provider. And the streaming provider is just a data class where it's got two attributes, a name and a price per month. And what we're saying here is that this name isn't just any old string, it is a streaming provider. So what we're doing is we're building up these really little tiny shareable atoms of data for us to start describing how our systems relate. Again, you do this automatically. So you do this yourselves when you're building these integrations. You're assigning these labels yourselves. We just don't have a great way of sharing them today. Okay, so here's my query. I'm going to say, right, I just want to find a list of films, give it to me as these things, and run it by doing an HTTP stream to Orbital that's running on localhost, and give it to me as a flux. So it's a nice kind of non-blocking operation. And all we're going to do is just print them out. Every time we get one back, we'll just print it out. So if I run that, and if the live demo gods are good to me, okay, there we go. So there's a bunch of films that have logged out at the bottom, right? Film ID 999, Zoolander Fiction, ID 1000, Zorro Arc. So that's cool. If we jump into Orbital's kind of developer tools, we can see actually what went on under the hood there. So it's not a good sign. Okay, so here's my query that I actually ran. And if we look at the profiler, it will show me what happened, and we just did a SQL query, right? It just we ran a SQL query to talk to a database, and it gave him back my ID and my title. Nothing particularly exciting. Hibernate could have done that, right? We stick with it; it gets better. Okay, so I'm going to flesh this out and ask for a couple more fields. So I want to know where can I watch it. I'm going to put this down. And I want to know what people are saying. Is it any good? So give me the review, which is a review score. and give me the text. Cool, there we go. Missing some commas. So all I've done, again, is just specified the fields that I care about, all right? I don't know where this data is coming from. I don't need to know whether it's available in my database or not. Spoiler alert, it's not. So I'm just going to rerun that query. Okay, and now we're getting a bunch more information logged out. Again, the data contract that I've specified is the data that I'm getting back, but I haven't had to talk about how to get it. If we jump back into Orbital and we take a look at kind of what went on, here's my query. We'll look at the profiler, and actually a lot more stuff happened this time. So we can see that the first thing that Orbital did was a database query to our films database to look it up. Sorry, try not to block your view. And then in order to get our review and our review text, we had to do sort of like what people are saying about my movie. Is it any good? We had to do a REST call over to our review service. And in order to get where I can watch it, we had to do a different call to a different service, and it told us the cost and where I can watch it. So I'm specifying the data contract that I care about. Okay, now that I've done that, and I'm happy with this is the data that I want, things are going to move on, and I'm going to break a bunch of stuff. So first thing that I'm going to do is I'm going to jump into my review service. Okay, so this review service, it takes in a film ID and it gives me back a film review. And things have changed in my organization, and we're no longer doing our own reviews. We've now outsourced it to this company called Squash Tomatoes. So Squash Tomatoes are now where we're getting our reviews from. And they don't know my film IDs. They have their own ID scheme, Squash Tomatoes film ID. So they're not going to tell me what our internal film ID is. They're going to tell me it in Squash Tomatoes. So let me just redeploy that. It's just like it's a tiny change, right? None of the field names have changed, but we know that field names are a bad proxy for semantics. The semantic contract has changed. So I redeploy my service, and I'll jump back into my query. And I'm going to rerun my query, and all things being equal, there we go. I've still got my reviews coming out. But how did that work? Well, because the IDs that we got out of our database, they're a different ID scheme. So if we jump back into Orbital to kind of take a look at what's going on, grab the latest query, look at the profiler. And because the semantic contract was different, there's this additional place that we've had to go to resolve the IDs. I've needed to swap out our internal film ID for the Squash Tomatoes film ID. Now, for me as a consumer, that's an implementation detail that I really don't care about. I'm not in the business of becoming an expert about different ID schemes in our business. I'm in the business of providing really cool information about where people can watch my really cool movies. So the implementation of detail of this, I don't care about. And really importantly, when that change happened, I was abstracted away from it. So we broke the semantic contract of a service, and the consumers were protected from it. Let's break one more thing. Okay, so here is my streaming movies provider. This tells me where I can watch my movies, right? And so our response is this nice kind of simple data class. And we've got this nice kind of simple GET request that's going on there. So let's break that. So our data class at the moment has 2 fields. So let's comment that out and bring in the much better version 2, which is so much more code. Ooh. Okay, so this time we've swapped our GET request for a POST request. That's a breaking change, that counts. Where we were passing the ID and the URL, now we have this request object that someone needs to construct, this streaming provider request. We have completely refactored our responses that are coming out. So we were just giving back a few fields. We've now nested some data. We've added a bunch of new data, and we've renamed all of the fields. So it definitely counts as a breaking change. I'm just going to republish that schema. So literally all I'm doing is restarting the service. When the service starts up, it publishes its schema up to Orbital. And then I will jump back to my query code. And let's rerun that query one more time. Again, for me as a consumer, oops, nothing has changed. And there we go. Here's all my reviews that are coming out. I'm still getting, still finding out that I can watch Zoolander Fiction on Disney Plus. Such a Disney Plus title. If we jump back over here and take a look and see what's gone on, we can see that a request has changed from being a GET to it's now a post. That's a bit tricky to see on the screen. You're going to have to take my word for it. There we go. It's now an HTTP post that we're doing in order to send that off. So we broke the verb. We changed the way to interact with it. We changed the URL. We refactored the response that we're getting back, moved things around, nested some stuff, changed the field names. But because we have a semantic contract for consumers, they're protected from all of that. We can kind of dive in and take a look at and understand. So actually, here's the actual query that's going on. That might be a bit hard to see. Let me zoom that in a bit. This is the actual kind of taxi query that's going in. So the Kotlin SDK is generating this for us based off of the types that it's passing in. So if I just run that in our IDE here, there's my results. But we can actually drill down a little bit further and go, right, how did we get to a review of 3.7? So 3.7 started off with, go all the way back to the start. It started off as a database query to which gave me back a film ID of 1, which then we passed into another service to look up the squashed tomatoes film ID of squashed 1, which we then passed into a different service to get me the film review score of 3.7. So because we're not building this integration, because we're kind of offloading it to something else to do it, we also get super cool observability, like what's actually going on between our systems. Okay, one last thing I want to show is, this is all well and cool, but we don't live in a request response world anymore. Like things are moving faster than that. Everything's about streaming data these days. So I'm going to jump back, and this time I'm going to say, right, rather than finding me a list of films, I want to stream these new film release announcements. So this is a message that's getting broadcast on a Kafka topic whenever Netflix announces a reboot of a 1980s sitcom. They put a message on this message topic. But for me as a message consumer, it doesn't have all of the message data that I need. I need to know the ID, the title. I need to know where people can watch this new rebooted 80s sitcom. And I need to know what people are saying about it. So this is the data that I need. So at the moment today, when we're building streaming applications, we're tightly coupled to the data that's on the message. Classic like architecture challenge. Do you have an anemic message? Do you have a big fat message? How do you appease all of your different consumers? And it just kind of shows that actually structural contracts become this really conflated concern, right? Everybody, you end up having to appease everybody or appease no one. Where in actual fact, what we're saying here is, I want to stream this data, but this is the contract that I want. So I can run that. So this time the query has changed because my needs as a consumer have changed. And we should start seeing, there we go, data getting streamed out as it's coming in. And if I jump back into Orbital and we take a look at that query as it's running. So this time it's quite a different integration plan. Oops, it's really tricky on a mouse pad. So we start off with a Kafka, we subscribe to a Kafka topic, we do all the protobuf deserialization, which me as a consumer, I don't really need to care about. We take that data and we feed it into a handful of microservices. Because Netflix is giving us the information using their ID scheme, again, it's different from the ID schemes that we've used for squashed tomatoes and for our internal films. So we need to call out to a different service to resolve those IDs. And then I can finally pass those IDs up to our review service and off to our streaming provider service to find out where to get it, and off to my films database to look up the title. And all of this stuff is kind of happening under the covers. I don't really need to know about how to do this. I can just say, this is the data that I want, and it's up to the middleware to work out how to do it for me. And when things change, it's up to the middleware to adapt. Here endeth the demo with no breakages. Okay, so summary is Kotlin type aliases is just a neat little way of talking about semantic metadata. Semantic metadata means less plumbing and loosely coupled consumers and gives us really, really super cool automated integration. Questions? Anyone?
Go for it, mate. Oh, okay.
Yeah.
I was going to say, well, that was very cool. But what happens if you are serving up the same information from two providers and say one of them's like really way slower than another one or something?
Yeah.
Between them, would you just be able to repeat that?
Yeah, sure. So the question is, if you've got two different places in your organization to get this information and one is slower than the other, how does it know which one to choose? At the moment, it optimizes for the least number of hops. So if it's the same number of hops to both of them and one is just kind of slow, that's unfortunate. But in the future, we're going to be doing stuff like caching within there and also dynamically optimizing as we're going. So if there are valid different paths, at the moment, it will take the first one. If that doesn't work, it will fail over to another one. But over time, we would look to improve that so that it chooses the most performant path. At the moment, it takes the fewest number of hops, which is not necessarily the same. Yeah, Lee.
So kind of Spring Boot example, is this kind of framework agnostic, presumably? Quarkus, Micronaut.
Yeah. So there's nothing in. I mean, we've kind of picked Spring Boot as our first thing because it's a stack that we know really well and it's pretty popular. But fundamentally, there's nothing specific to any technology that's going on here. So the kind of generation that goes on happens through a plugin that we build. You could build your own plugin for Quarkus or for Micronaut or whatever. And equally so, you can do it for other platforms. So for TypeScript, for Nest.js, for C#, for whatever the framework is there. But yeah, fundamentally, it's framework agnostic.
And when you started your services, they registered the metadata with Orbital. How does everything? I didn't quite get how everything got in there, like the database. How are all the connection systems registered? Is that a manual task within Orbital to set up all those things?
Cool. Yep. Good question. So the question is, what dirty secrets was I hiding? I showed a Spring Boot service starting up, but how did the database get there? How did the Kafka topic get there? Yeah. So, I mean, for the demo, I just didn't show those bits because it's kind of dull. But fundamentally speaking, we're not particularly opinionated about how and when you publish your schemas. So in this example, I showed it in applications on startup because it makes for a better demo when I'm restarting apps. You can do it through your CI/CD pipeline to push them out. If you have, or you can, within the UI, you can just point directly at a Git repo and say, I want the API spec that lives in this Git repo at this location, and then Orbital will poll that Git repo to pull it in. Fundamentally, we're not prescriptive around how we get the schema. It's just around finding the different schemas and stitching them together.
I've got more questions, but if anybody else wants to jump in, feel free. The mic across to you if you have more questions. Should we do that?
Yeah, sure.
Yeah, you guys get more questions ready. And
Thank you. So kind of worked in places before that have had like a steady growth of microservices, usually kind of connected by like, I don't know, Rabbit and Protobuf and things like that. What's the migration path? What's the easiest way to get started with this for, let's say we've got, I don't know, a good like 50, 60 microservices and there's a random jumble of Rabbit queues all over the place. What's the easiest way to get started? Is it just literally take one and start that way? Or?
Yes. Yeah, no, it is. The idea is start small, build something that is going to give you incremental value and iterate from there. The other part to your question that I missed earlier around what are all the different parts that are in here, the part that I haven't shown in this demo is that kind of central taxonomy, that collection of semantic contracts and how we build them. So I showed the Kotlin type aliases from them, but in actual fact, we define those using Taxi, which is a framework agnostic metadata language. And so that is a thing that lives in a Git repo somewhere. So the way that it works is you go, okay, great. I want to integrate a couple of services. Let's look at their APIs. Let's start defining some semantic contracts between them and start factoring that out. Create a taxi project, commit them into the Git repo, point Orbital at the Git repo, and it will start pulling in those changes as they're coming in, and then start using those same semantic tags in your API specs, whether it's OpenAPI or Kotlin or Protobuf for Rabbit.
So Orbital in your demo was running a local host. So is this like a self-hosted solution? And have we got kind of like a single point of failure kind of thing?
Yep. So that's two separate questions. So yes, at the moment it's local. It's self-hosted. So Orbital is just a Docker image that you can pull down and start tomorrow. And please do pull it down and start playing with it and give us some feedback. Jump on our Slack channel. Promote. But yeah, just download and play with it. It's designed to run on-prem because it's integrating your microservices. It's going to live behind the firewall and exist in your ecosystem. Is it a single point of failure? No. So it's designed to be highly tolerant. So you can run, there's a few different components that are involved, but fundamentally you have a schema server that's responsible for pulling in all of those different data sources. And that's the thing that I'm publishing my schemas to. And then you have query servers that are responsible for executing those queries that I showed. And the query servers can scale independently and you can scale them up and down. And we've got some Kubernetes Helm charts coming out shortly with auto scaling on the query servers. And the schema servers are designed to be highly available and active.
Is that the easiest way for us to try this out?
Yeah, absolutely. If you go to orbitalhq.com and go to our docs on there, there's a bunch of kind of getting started guides, and there's also a link to our Slack channel. So join the Slack channel and chat to us and talk to us, and please play with it because we are very actively building in this space and very actively iterating. And we know that our kind of developer onboarding journey could do with a bit of work. So people downloading and playing with it and giving us that feedback, that's kind of gold to us.
So I think, sorry guys, I will stop it for a second. I can't get out this beanbag. It's getting that way, mate. It's getting that way. Online, Anthony has asked, so I'll read it out loud. Although you've mentioned that it is easier to agree on semantics than structure, don't you think that the problem sort of remains? Example, when things go wrong, instead of having a messy common canonical model, you have a messy set of semantic types and ineffective integration routes because people can't agree on semantics.
Kinda. I kind of agree with that, but not entirely. I think that, there's a couple of questions in there. I think having one big enterprise domain model that everybody agrees on is really, really hard to do well. And generally the effort that goes into building that and agreeing on it doesn't tend to pay dividends because it's a thing then that becomes a choke point around iteration. How do I evolve my enterprise domain model when things invariably change? And they do. Semantics don't evolve at the same pace as systems, right? I'm not saying that it is easy to define semantics. I'm saying it's easier. It's much easier for us to agree on what terms are because we already do it, right? We already do this, and that's kind of the point. We are already doing a lot of this stuff. We're just doing it in a really informal, ad hoc, kind of spur of the moment, on demand process, right? Every time you build a consuming integration, you are doing this process of semantically inferring contracts and coding against them. We're just not writing it down, which means we do it over and over and over and over. The semantic contract exists, right? The IDs between these systems that link together, that semantic contract exists. All we're saying is give it a name. Any other questions in the room?
Okay.
Cool. That's it. Please download, have a play, join us on Slack, come and chat.
Awesome. Thank you. Thank you, Marty. Just before you sit down, how do I get back to the other slides without breaking your laptop? Nice. Perfect. Awesome. Well, thank you for that. That was an excellent talk. Lots of food for thought. Just before we kind of break for the evening, we've got up and coming events that Silicon Brighton is supporting. Go to the QR code, siliconbrighton.com events. And our next meetup is already on meetup.com. We're still looking for speakers for both Java and Kotlin. So if you've got anything you want to talk about, feel free to get in touch and we'll get you booked in. Silicon Brighton have a really, really active Slack community across the whole tech space. So I would definitely recommend joining there. They've got all of the meetup organizers and a whole load of other people in the tech space in Brighton. So it's a really kind of active, welcoming community. I would definitely recommend joining. We're on there on the Brighton Kotlin and Brighton Jug. So come and say hi. And I think that's it for this evening. Like I said, we'll be drawing the winner for the DevOps ticket once we've collated all the names. So if you receive a message from me, then you'll know that you're the winner. If not, then better luck next time. Awesome. Thanks for the speakers. Thanks for coming in person. Thanks for all the people who came online. Hope to see you at the next meetup. Have a good one.